This is Algebra 2, Lesson 3.2, Solving Systems of Inequalities by Graphing. The first thing you guys will need is a piece of graphing paper. Each graph needs to be at least 10 by 10, and you will need 6 graphs on this. The first one is y is less than or equal to 6, and y is greater than negative 3 plus x. These are both linear inequalities, so we're just going to go and we're going to start graphing them. The first one, y is less than or equal to 6. It's a solid line where y is 6 always. And so this would be where y is 6 always. The second one is a linear equation as well. It crosses at negative 3, has a slope of positive 1, so it needs to go up 1 over 1. And you need to fill your graph with both of these. You have to fill them at least so they cross and have at least 4 visible sections here. It's a dashed line, and you kind of got your pattern too. We could go on out there. So you have 4 different sections. Section 1, Section 2, Section 3, and Section 4. You have to shade on these because they're in graphing inequalities, and you have to shade what's in common between both lines. So let's take the first graph for example, just the y is less than or equal to 6. If we test 0, 0, we get 0 is less than or equal to 6, which is true. So if we were just shading for that one line, we would be shading anywhere below, which would be areas 3 and 4. With the other line, though, when we plug in 0, 0, we get 0 is greater than negative 3. Well, that's again true. 0 is greater than negative 3. And so if we were just shading for this line here, the x minus 3 line, then we would be shading areas 1 and 3. Because that's the stuff on the true side. That's the stuff that's on the 0, 0 side. And so the rule that I have is to put x's where you would shade for each line in the sections, and the one that has both x's is the one you shade. So you're shading this part because this is what is in common. So again, I like to shade, get it all covered up. And so you're shading what's in common. So anything in this area is a solution to our system of inequalities. Okay, let's do another one. We have y is less than or equal to negative 3x plus 4. We also have y is greater than or equal to 2x minus 1. If these were not in slope-intercept form, that's the first thing you would do is put them in slope-intercept form. Second is go graph. So we start at positive 4. On that first one. It was a negative 3 slope, so we go down 3 to the right 1, down 3 to the right 1. And then you can also continue your pattern by going up 3 into the left 1. It's a solid line because it's got the equal to with it. On the second line, it crosses at negative 1. We'll do it in black here. Crosses at negative 1 and goes up 2 over 1. We also go down 2 and over 1. Solid line as well. Okay. Now we have to do our test points. On the first one, if we plug in 0, 0, we get 0 is less than or equal to negative 3 times 0 plus 4. So we have 0 is less than or equal to 4, which is true. So the black line is the one that we graphed first. And so we have true. 0, 0 is true, so you're shading here or here. Now let's go check the blue line. So if we plug in 0, 0, we get 0 is greater than or equal 2 times 0 is 0. 0 minus 1 is negative 1. Well, 0 is bigger than negative 1. So when we go back, this blue line, this is where 0, 0 is at. These are the two, this is the side of the blue line that's true. And so the one with the double X's is the area that we shade. Okay, there's number 2. Let's graph number 3. X is less than 3, and y is greater than or equal to -4. So if we go to our graph, the first one's going to be a dashed line, and it says x is less than 3. So we graph it where x is always 3, and that's this one. And then on the second one, it says it's going to be a solid line. Y is greater than or equal to -4. So that would be that line. So if we plug in 0, 0, 0 is less than 3 for the first graph, the dashed line, which is true. 0 is less than 3, so it's either going to be here or here. With the horizontal one, we plug in 0. It says 0 is greater than or equal to -4, which would be true. So it would be here or here. The one with the double X's is the one we shade. So this would be the square that we shade here. Okay, let's do one more just like this. So we have y is greater than 3x minus 5, and we have y is less than or equal to +4. The first one crosses at -5, up 3 over 1. Crosses at -5, up 3 over 1. And it was a dashed line. The second one was a solid line at y equals 4, so right here. If we plug in 0, 0, we get 0 is greater than -5 for the first one, which is true. So this is our first one. 0, 0 is true, so here or here. The second one, 0 is less than or equal to 4, again true. So below the line, this is our one with 2 x's. Okay, so the next section says find the coordinates of the vertices of the triangle formed by each system of inequalities. When we're finding the coordinates of the vertices of the triangle formed by each system of inequalities, what we're finding is the crossing points of all 3 lines. So again, all 3 of them have to be in slope-intercept form. So the only one that we need to change here is this x plus 2y is less than 4. We'll subtract that x over, and we have 2y is less than -x plus 4. Divide by 2, and so y is less than -1/2 x plus 2. So let's go graph the first one. X is greater than or equal to 0, y is greater than or equal to 0. So with that, when you graph it, this is where x is always 0, and this is where y is always 0. So each axis there. And then on the next one that we're graphing, we start at +2, we go down 1 over 2. So start at +2. Let's change that color. We start at +2, we go down 1 over 2. Down 1 over 2. You could also go up 1 over 2 as well. Get a good line going there. So what it's wanting is this point, and this point, the line that makes the triangle. So you just write the coordinates. So you would say 4, 0, just here, 0, 2 at the top, and then we have 0, 0. That's your answer. They're not wanting you to shade. All they're wanting you is to find the coordinates. So let's do one more. Okay, so our next problem that we're going to do is, let me find one for us to do real quick. x plus y is less than or equal to 9, x minus 2y is less than or equal to 12, and y is less than or equal to 2x plus 3. So we've got to put these in slope-intercept form. So the first one, we have to subtract the x over. The second one, we're going to have to subtract the x over and then divide by -2. So be careful on that one. So if we've subtracted the x over, we have -2y is less than or equal to -x plus 12. But when we divide by that -2, remember you have to flip your sign. So y is greater than or equal to -1/2 x plus 6. And then the last one's already in slope-intercept form. So the first one, it crosses at 9. Let's erase this. It crosses at +9 and goes down 1/1. So solid line on that one. The second graph crosses at +6 and goes down 1/2. Also a solid line. And then the third line crosses at +3 and it goes up 2/1. And a solid line as well. So now we can find our points. It crosses at 6, 3, 2, 7, and 1, 5. This concludes Algebra 2 Lesson 3.2, Solving Systems of Inequalities by Graphing.